can be applied to robotic arms, right? In industry, we use robot. So the robot will rotate in different direction, and then it can elongate and can retract. It can go up and then go down, can retract, and extend, right? So this concept is important. So you have a block mainly frictionless. Look at the keyword frictionless arm. Okay, OA. So which rotate in horizontal plane at a constant rate theta dot. Okay, theta dot, right? So it's rotate. Okay, imagine this one. So originally in here, right? And then it's moving. Okay, it's moving. It's going up. Okay, with angular rotation, right? With angular rotation. So it's being given here theta. Okay, theta dot. Okay, I want to enlarge this one. Cannot see. Okay, this is slightly bigger. So here we have you are given here, this is theta, theta dot. Okay, so this theta dot is basically is theta dot here, right? Which is basically what is theta dot? Theta dot. What is theta dot? Angular velocity. Okay, angular velocity. If theta is angular rotation, right? If theta dot is angular velocity. How about theta double dot? Angular acceleration, correct. So just to recap what we have learned there, to make sure we are very accurate. So we have here, we have theta, okay? This is the rotation of it, which is counterclockwise, okay? So this is the problem. Rotate in horizontal plane at a constant rate theta dot, okay? Theta dot, which is angular velocity. So by knowing, okay, that B is released, okay, at the distance r dot from O, okay. So what we understood here that this B, it can slide freely, right? If we have originally it at here, okay, when you rotate, okay, when this arm OA is rotating, so this block B will go in which direction? Is going to go this way or this way? Is going to be outward or inward? It's not up or down. It is outward or inward. If you say this upward, it's going to go this way, upward, right? Going up. If going down, it's going down this way. Now we are talking about this arm, OA, right? OA. If because when it's rotating, okay, now okay. When it's rotating, it's moving along OA, right? So start from here and then this place somewhere here, right? So it must be along. So I say If this way, at this instant, this is upward, and this is downward. Okay, we are rotating this arm. So it's going to be in this direction, which is upward. So knowing that A is released at distance r from O, expressed as a function of r. Okay, we want to express the relation in the function as a function of r. Okay, what we want to find? A is to find the component of VR, okay, of velocity of B along OA, okay, and then B, we want to find the magnitude of the horizontal force exerted on B, okay, by the arm OA. So these are the questions that been asked for this problem, okay. So our strategy to solve this problem, okay, is to be as the following, okay, as the following. Yeah, it's going to be as the following. First thing, you need to write the radial and transverse equation of motion of the block. Okay. When you look at this type of problem, this figure, you have radius r, you have theta, and you have the rotating, the moving object like this. Okay, this one is related to radial and transverse type of coordinate system. So we can apply this type of equation. So you write down radial and transverse equation of motion for the block, and then you start to do the integration of the radial equation, okay, to find the expression for radial velocity. And then you do substitution. Okay. All right. Now we're going to take time to do this. Okay. So look at how they draw the free body diagram of it. Okay. I give you 1 minute to look at that figure and then how we do the solution of that problem. Okay. If you see the diagram of it, okay, we have the diagram here, right? We have 0 here, and then the theta, right? The theta. So we know that since all other forces, they are perpendicular to the plane, right? They are all perpendicular, okay? All forces, they are perpendicular to plane, okay? Okay? All other forces, okay? All other forces, okay? All other forces, they are perpendicular to the plane, right? The plane of the figure. So the only force shown acting on B, okay, is the force perpendicular to OA. Okay, so what we have here, we show what will be the force which is the perpendicular to OA. So this is OA, right? Oh, that doesn't roll nicely. It's okay. So this is OA, along OA. So we have here force perpendicular to A. Okay. So we have here, this is summation of force. This is for kinetic diagram of it. We have AR, MAR, and then we have here MA transverse. Okay. This is the basic one that we need to know. So now we start to write the equation of motion. Okay. We want to write equation of motion by using radial and transverse components. Okay. So this one, we write summation of force in R direction. So going this way is positive, right? Yeah, going along here is positive. Okay. And then for transverse equation, this direction is positive, right? This direction, sorry, this direction is positive, going this way. Okay, going this way is positive. So we can write summation of force of R. Okay, here we can write FR equal to MAR. Okay, the one that we have went through just now, and substitute the equation of the equation. I name this one as equation 1. Okay, this is equation 1. And then here we have summation of force transverse. We substitute expression of transverse here. This is equation 2. Okay, equation 2. So we have equation 1 and equation 2. Okay, this is the basic, these are the basic equation, okay, for this problem. Okay, for part A, okay, for part A for this question, what been asked there? You need to find the component of VR, right? Component of VR. We have to find the component of VR. Okay, component of VR, which is the of velocity. Okay, component of velocity. So we know that VR, is equal to R dot, right? VR is R dot, right? VR is R dot. Therefore, we will have R double dot. Okay, so you proceed here. Oops, sorry. So you take there. Now is R double dot. Okay, so R double dot is basically is V dot R. Okay, so we start to do the substitution over there. Okay, this is what we've been doing here. Okay, that's what we've been doing. Okay, so we start to do the derivation of it, which is dVr dt equal to dVr dr times dr dt. So which is Vr times dVr dr. Okay, and then you substitute here, you get VR dr, okay, and then you proceed again to write in term of dvr equal to r theta dot square dr, okay, you substitute theta dot to be theta dot square, and then you start to do the integration of it, which is you integrate both sides, you get VR dr, integrate from limit from 0 to VR equal to theta dot square and times r dr integration from r0 to r, and then you get the velocity, the value of VR square. Okay, you get the value of VR square is in this term, which is VR square equal to theta dot square, okay, times r square minus r dot square. Okay, so what is VR? What is VR? Now we have VR square, but the question asks you to find VR. So how do you get VR? Square root. Yeah, correct. Square root. Of course, let's take the square root of that. Okay. Same student answered my question. What happened to the rest? Are you with me or not? Hopefully you not just not sign in and then do something else. Okay. So use the class time to go through this so you can study other class later on, right? Okay, here. So if you want to find here, so you take this one. So V R, okay, equal to, okay, theta dot, okay, theta dot, okay, theta dot. So you have R square minus R dot square, okay, and then square root, right? Square root of it, okay. Okay, that one is part A. Okay, this is for part A. All right, this is for part A. Now we proceed for part B, which is we want to find the horizontal force F. Okay, for part B. Part B, need to find horizontal force. Okay, horizontal force. So what we have here for horizontal force? What we know? For horizontal force, we set theta. Okay, we set theta dot equal to, okay, theta dot, right? So what will happen for theta double dot? What is the value for theta double dot? Okay, This is BR. Okay, BR is theta. This is correction from your friend. Thank you. Basically, this is BR. BR equal to theta. Okay, this is theta dot. Okay, theta dot. Not this one. Theta dot. Okay, BR square. Sorry. Oh, this is correct. I'm sorry. Yes, to go back. Okay, this one. This is BR. Go back. This is BR. BR square equal to theta dot. Okay, theta dot square. Okay, times R square. Whatever there is already correct. So R dot. Okay. So VR square equal to theta dot square times R square minus R dot square. Okay. So you want to find VR. So you have here VR is theta dot times okay, times R square minus RO. This is 1 over 2. This is square root 1 over 2. This is correct already. Okay. We proceed to this one. Substitute theta. So theta double dot. This is constant, right? Theta dot equal theta dot. So theta double dot will be what? It's 0, right? This is 0. Because you differentiate constant, so you get 0. Okay. And R dot, now another one is R dot. R dot equal to VR, as mentioned earlier. Okay. So you substitute for VR and then you get this expression. Okay. You get this expression which is F equal to 2m theta. This is theta dot. This is theta dot square. F equal to 2 times m theta dot square times R square minus R dot square. Okay, square root and then multiply by theta dot. Okay, dot 0. Okay, and then you can substitute the value and get the answer for that. Okay, to make it clearer, I will WhatsApp you the detailed solution of it. Okay, if you still don't understand, maybe you can clarify again.